This is Janelle Mann here, and I'm going to be talking to you about sources of data. One of the things you're going to notice in these videos is I'm going to be writing as I speak. And I know that slows down this video a little bit. However, I use it on purpose because it's very easy for me to speak too quickly. So I'm going to write as I lecture, and I encourage you to write on a tablet or write on a piece of paper as well, because that'll allow you to focus on what we're talking about. So we're going to talk about three different types of data today. We have anecdotal data, and this type of data is around us all the time, and it's actually extremely misleading. So anecdotal data is based on haphazardly selected cases. Which often come to our attention because they are striking. For example, you might have a friend that tells you, I had a RAV4, I drove it for 15 years and put on 300,000 kilometers and never had a repair. You should only buy Toyotas. They are the best car. I'm sure we've all received advice like this, but we need to be very careful because that is very misleading. It's based on one person's experience with one vehicle of that particular brand. Sometimes it's especially the case when a person we really trust tells us this because we think that that data has more value than it actually has. So anecdotal data is all around us. We just need to be very cautious in how we use it. The next type of data is called available data. So available data is data that is produced for some other purpose, and we are using it to answer our own research question. So this is data that were produced in the past for some other purpose. And we are using it to answer the present question. So one really great example of this is Statistics Canada. Statistics Canada is run by the federal government, and it collects data on Canada. So it collects things like mortgage rates and interest rates that are offered by various banks and other financial institutions across Canada. It calculates the consumer price index. It has data sets on things like unemployment, as well as different areas of employment. We are actually going to look at CanSIM together. This is a database produced by Statistics Canada that houses Statistics Canada data. So in our next segment, we are going to be doing this together. So an example here, I'll put my examples in a different color just to remind you of them. So an example here is CanSIM. And an example that I talked about for the first one was the Toyota example. In my own personal research, I use available data almost all of the time. One nice thing about available data is that you can take a look at how the data was collected and make sure that it is completely valid, but it's often very quick to access. So in the past, I have done some research that looks at the relationship between emissions per capita, so things like CO2 emissions, and GDP. Both of these series are available data. Sometimes you must pay for them, but they are available. So I was able to find CO2 data and SO2 data that dates back hundreds of years. I also was able to gather data on GDP for different countries and investigate their relationship. Of course, GDP only goes back so far. We actually have emission data that goes back much further. And so the study length is determined by the data series that is the shortest, I guess, would be the easiest to explain it. So that's one way I have used available data in my own research. Another way to use available data is things like physician claim data. So I'm trying to make this class as applicable to the University of Manitoba, which is in Manitoba, which is in Winnipeg, which is in Canada. I know you are watching these videos from all over the world, but I do really want to give you information that is specific to our situation. So in Manitoba, we have this really, really great database housed at the Manitoba Centre for Health Policy. And what it is it is a database that contains every single physician claim data, every single hospital visit data, as well as every single every single time a person fills a prescription at a pharmacy. And so this data is very, very protected. It's encrypted. You need multiple passwords to access it. And even before trying to access it, you need to pass many different research ethic board approvals. However, it is very, very unique data because in Manitoba and in Canada, healthcare is a publicly provided service, which means that every time a person visits a doctor, they submit a bill to the province, and those bills are recorded. So we're able to use this data and link it up with other socioeconomic data to come up with answers to research questions. So for example, I recently worked with a PhD student who was looking at telehealth visits. So this is where you would visit a specialist, not in person, but rather you would have a video call with them. And she compared that to the health outcomes of people who had in-person visits. This was extremely timely research because she finished her research before COVID-19 happened. And at this time, this is where video calling became the norm. And so many doctors immediately moved to having teleconferencing with patients. However, before that, it was something only available to people who are visiting specialists or who are very remote and were not able to, for some reason, come in person. That is available data. Our third type of data is sample surveys and experiments. So this data is not available. It's something that the researcher would need to collect. So there are a few things that are very important to discuss when we're discussing collecting data. And a lot of these topics are brought up in chapter 3. We're just going to cover a few of them in the lecture, and then we will cover a few of them again next lecture. So before we do that, I want to define two things for you. I want to define population, which is a group of cases we want to study. And a sample, which is a subset of the population for which we collect data. So let me give you some examples here. So a population might be Econ 2040 in-person sections at the University of Manitoba in the fall session. A sample would be a subset of this population. There are many ways to collect this subsample from the population. So one way would be to write each of your names on a piece of paper, put them in a container, and draw out the names. That is one way. Another way would be just a voluntary response survey. I could send you an email with a survey in it and ask you to respond. So now I just want you to think about this for a minute and compare those two methods. So I'm going to just draw you two pictures here to help you remember what we're talking about. So within this first one, it's a container, and on each of these pieces of paper is your name. And the second one is the email, and I'll just put the subject line would be like something along the lines of Econ 2040 survey. For the one that we put all of the people's names in a container and drew them out, each of you had an equal probability of your name being drawn. On the other hand, with the email, each of you have the opportunity to fill in the survey, but who do you think would tend to fill in the survey? Well, it tends to be the people with the strongest opinions. So it would be somebody who would have a very hopefully positive experience and want to fill in the survey. But what we will notice is that often it's people who have a negative experience. And so this is one negative thing or one disadvantage of a voluntary response survey is that when you analyze the data, you have to always keep in mind that it's people with the strongest opinions who are most likely to respond. Now let me introduce to you something called a simple random sample. This is a very important concept, and so I'm actually going to write out the definition again here. So a simple random sample is this one here that we gave an example for above, putting the names into a container and drawing them out. So let me first of all write out the formal definition, and then I'm going to relate it back to this less formal illustration above. So it's a simple, oh, I'm sorry about that. Let me go back for a second. A simple random sample of size n consists of n cases from the population chosen in a way that every set of n cases has an equal chance to be selected. So if you think about this example here where I had the bucket and a person drew out a name, if we had, I'm going to add on to here now. So this will be my example. So I'll go back to the green. So if let's say you have a hand, here's my hand, and I grab one of these names. This would be a sample of one. It would be one case from the population. On the other hand, if we wanted instead to create groups, so let's say I wanted to create a focus group to help me learn about how Econ 2040 is going, and in my focus group I wanted to have 8 people, then I would draw, ooh, that's a very big hand, but we want to have 8 names. And since we need to make sure that the probability of being chosen is the same. When we do simple random samples, we always need to make sure that we replace the name back into the pail or the bucket where the names are. Of course, one person is not going to be on the focus group more than one time. So in this case, it doesn't make a difference if you just hold the person's name in your hand and collect all 8. But if you wanted to create a second group, you have to put all of the names back in and pull them out. So you always need to make sure that people have an equal chance to be selected. So one way of saying this differently is that not only does each case have an equal chance to be chosen, which means thus avoiding bias. But it gives every possible sample an equal chance to be chosen. So that is all we're going to talk about the simple random sample for right now. But I want you to scroll back here just for a moment. So we're talking about sources of data. So we have anecdotal data, available data. Then we were talking about sample surveys and experiments. Then we introduced population and sample. And now I want to introduce a few other terms. One of them is census. A census means that you are going to sample the entire population. One thing that is good about a census is that every single person gets to voice their opinion or share their data. On the other hand, a census is extremely expensive to conduct, and it's very hard to get 100% compliance. Now we're going to talk about 2 other ways that we can collect data. So we have talked about sample surveys, now we're talking about experiments. So let's define an experiment. This is where we deliberately impose an intervention. On cases to understand the cause and effect. So we've often heard about experiments. One typical one that you would see here in Manitoba is testing different seed, chemical, and fertilizer combinations on crops. So when I was a student in the summer, I would work for different companies that would test these chemicals to see how they perform. So instead of having one big, huge field, so this would be the big, huge field, a farmer would regularly farm the whole thing, we would break it up into these very small plots. I mean, small relative to what a farmer would normally farm. And then we would test different seed, chemical, and fertilizer combinations. So each of these ones, so this one here might be seed A, fertilizer 1. This one might be seed B, fertilizer 1. This one might be seed C, fertilizer 1. Then we would have here ABC again. And instead we'd have fertilizer number 2. And then we would have this many times across the field where we would change up the order. We would not always go A, B, C. We might go A, C, B. Then we can go B, A, C, because we want to make sure the only difference in these experiments is the actual, we want to understand the relationship and the cause and effect relationship between the fertilizer and the seed on the actual product, the seed or the grain that is harvested. And one thing that is quite interesting is actually Manitoba is a place that a lot of testing is done, because in Manitoba we have many different soil zones. And because people farm in many different soil zones, there's not necessarily only one best fertilizer seed combination. There might be something that differs by soil zone. So we would repeat these experiments in many different locations across Manitoba to be sure that we have a cause and effect that can be used by farmers to make their own decisions. And we have one last thing for today, and it's going to be called an observational study. In this case, we collect data, we collect information, but we do not have any intervention or treatment. So basically what this does is it gives us a picture of the population, disturbed as little as possible. So when you think of certain things in nature, it makes sense to have an observational study. Let's say you were studying endangered species and you wanted to try to figure out the role of certain habitat on these endangered species. Well, you can't just move the endangered species to different habitats because it could be detrimental to their survival. The same thing is true for economics. You can't look at people from the University of Manitoba getting an economics degree and place them into different jobs to see how they perform. We can't do an experiment over many years putting people in different careers. So instead what we can do is observe where people who graduate from economics degree at the University of Manitoba, where do they end up getting employment? Do they end up going somewhere else for graduate school first? And then we can make some data sets by following these people over time, but there's no specific treatment. So that is one example in economics. Other ones are just like interest rates. We can't apply a certain interest rate, say a prime rate, to certain portions of Canadians and a different prime rate to other portions. It doesn't work that way. There's one prime rate for all of Canada. So that brings us to the end of this first video.